Hello and welcome to this video. This video is part of the machine learning tutorial class for September 19th. And in today's video, we'll be looking at how to deploy a model and make an end-to-end machine learning project. So this is really exciting because until now we've made a few models, we looked at a little bit of theory, but most of the models just reside on our own model, lest if we save it and so on. But today we're going to be deploying a website which is hosted through a Flask application, and we can access this from anywhere and on any device. Now, if you do not know Flask or if you do not know how to deploy things, please don't worry, as it will all be covered in this video, and also we'll only be using the basics of Flask anyway, so a lot of the syntax is quite intuitive. That said, all of the code will be hosted on the repo, so please check it out if you haven't already, and you can also follow along if you want to. Now, if you do deploy this application, or if you are not part of the ML course and if you have any doubts and if you have any issues, please feel free to leave a comment in the video, or if you want, you can also reach out via Slack or so on if you are in the class. That said, let's get started. So the project we're going to make today is basically a part of this project called Neutralize Carbon, also called Garden with a GUARDEN. So this was a hackathon project made by Neil, um, Ashwin, Saket, and myself. This was almost 15 months ago. And this project is really exciting in itself. I encourage you to go check it out later on. But we'll mostly be using this crop recommendation part of this project for today's demo, and we'll be using this dataset, which was taken from the Indian government database. Now, another common problem that you might face while starting off an end-to-end ML project is if you don't have any data, or if you can't find any data. And there are many sites like Kaggle and data.gov, but oftentimes very nice and quite good quality data is also found on the official government websites themselves. Like in India, we have data.gov and so on, and you can always find such data sets, or you can even make them yourself using whatever you want to, web scraping techniques and all that. So that said, we are going to be using this data today, so let's just save this. Before that, let's start a new repo. So let's make a new repo. So the reason I'm making a repo will become apparent as we start the deployment process. It just becomes more easy to extract all of the contents. So let's make a license here. So we've created a new repo. Now let's clone it to our local system. Now obviously we do not need to fork it. I don't need to fork it because it is my own account. But if it's someone else's account, I encourage you to fork it. So I'll make it in the desktop directory. Right now, let's open up VS Code. Until then, this is the data in the CSV format, which I will now copy until the VS Code loads, which it has. Let's anyway look at the columns themselves. So NPK are the soil percentages of these three elements. Temperature, humidity, pH, rainfall are self-explanatory. So these are all soil properties what we're looking at, and label is the crop we're going to grow. So we have a set of around 5 or maybe more crops like rice, we have maize somewhere here, we have chickpea and kidney beans and so on. Pigeon peas, interesting name. And so what we want to do is, ideally given soil, so the end user, what they would do is they would go and somehow measure these quantities of their soil, or let's say they're a farmer and they know all this, or they can measure it. Then we can recommend what they would like to grow or what would be best for them to grow based on past data. Now, obviously, an obvious question would be, well, how would I get these data points? So I went on the hunt for a few APIs, and we could find something for like temperature and humidity and pH. But NPK values were quite hard to find. That said, given we have NPK values, we can get this data for pretty much any latitude and longitude. And also, there are some hardware devices which Neil had in the hackathon, where he used his hardware controller basically to harvest these values from his place of residence. So that said, now we have the CSV files. Let's make a new folder in VS Code. Let's make a new file. Let's call this crops.csv, and let's paste this in. All right, now that we have all of this, now let's make a new notebook. So let's make it in the parent directory. Why not? So since this is in the ML course, XGBoost has already been completed by the professor, and it will also be recapped in the tutorial session, which is why we will be using XGBoost in this notebook. Now, of course, choosing your model itself is quite a loaded process, and that is something that I encourage you to check it out. But for today's experiment, today's tutorial, whatever you will, we will be using XGBoost. So let's call it model train of CSV. So obviously, my bad, this is not a CSV file. Let's rename this to INB. Now, obviously, another important thing is it's quite hard to deploy IPyNV files, so we have to save the model somehow, and we will be doing that here. So first, let's import pandas, and let's run this. This will take some time. All right, let's look at the data. As we just saw, we have nitrogen, phosphorus, and K. We have temperature, humidity, pH, rainfall, and label. So label is what we want. K is potassium, and label is what we want ideally. So now let's look at some null values. Why not? So, and this is something that you would have studied as well, that XGBoost, if you have null values and let's say a string or a float column, it will assign default values. So it's quite a sketchy process if you have null values. Luckily, we don't really have any. Now let's also look at if any of the columns are like negative. So let's look at def.describe. So let's look at the mins here. So we have one nitrogen at 0. I think that should be fine. And we don't really have any negative values. Now, of course, you might note that there is quite a drastic maybe range of values here. So we have 20.2 to around 298.5. So we could standardize this, and there are many methods of standardization, which I would leave as an exercise for you, the viewer. I encourage you to try it out and let me know all in the comments or whatever, what results you got, if you got better results or not with standardization, and what you tried. And that's it. Let's maybe create X and Y. So let's drop the columns of the label. All right, now let's look at Y. We can see that these are rice and coffee. All of these are like strings, right? So obviously, to pass it through XGBoost or pretty much almost any model, we have to now convert this into some kind of encoding. Maybe rice is 0, coffee is 1, and so on. So to do that, there's something called label encoder. So let's quickly Google this. By the way, this is in this recording in such a way where we do a lot of Googling. So I hope you're very excited with that. This is mostly how most projects are done. So it's quite hard to really learn all the syntax. That said, let's see how we can do it. So let's import it, and this is the label encoder, and we have to, I think, fit transform it is called. Yeah, we have a fit and a transform, so let's do that. So let's rewrite the label column. Okay, so let's look at the value counts maybe. So we have roughly 20 crops, and we have around 100 ones of each. Now you can see a very practical difficulty with this. That is, sure, we might get a prediction, but how would we map that back to rice and coffee or so on, or any of the crops? Because obviously if we're going to deploy this as an end-to-end project, we would need to know that information to supply it back to whoever had queried for this information. So let's look at how we can do that. So we need basically a kind of dictionary, label encoder. Yeah, I think I searched for this before. Right, so let's see. So what they do is this. So let's point that. Right, so we can see that this is the dictionary of all of the crops. Okay, let's continue. Now that we have the mapping dict, let's print them out and let's save this to a Python file. We could use pickle for this, but I'll just use Python file for this particular case. Right, now that that's done, let's now continue with our progress on making the model itself. Let's reset the while, and now let's look at the head of while. Yep. Okay. Now that that is done, now let's look at something that's known as randomized search CV. So this is something that we discussed in the previous class as well. That is, if you have a lot of hyperparameters, how do you tune them, or how do you choose the best one out of maybe a set of different types of hyperparameters? And there are many types of grid-based methods like grid search and randomized grid search. And today we will be looking at the randomized search. So let's maybe open up the documentation. Search, it's ZNet. Yep. So let's look at this. So what it basically does is it implements a fit and a score method for a lot of these input parameters that you give. So you have to supply it as a kind of dictionary, and then you can tell how many samples you want to take from that set. So what I mean by samples is, let's say you have k of type 1 and m of type 2. So you have total k into m samples, out of which you take, let's say, 5. So I think by default 5 itself is taken, so that we will be using 5 for this case. Now before that, let's install XGBoost. Now, as just a side note, XGBoost is also there in terms of XGBoost regressor, and I think it's called XGBoost classifier in sklearn. However, for this one, I found that this gave me more stable results for the last time we used this library. So I'm just using XGBoost itself. Now, keep in mind that we do have to save these things, these pip modules that we do install, at least the version numbers. That way we can then install them on our deployment server, wherever it is. That's it. Now that we have XGBoost, let's just do it. Let's first import this. So let's look at the example. Now the important part here is that you can see over here you have a CV, which stands for cross validation, and we went through this last time. Because we're just finding the best model as of now, we will not let's say divide the data into train and test splits. We will use randomized search CV, get the best parameters, and then train it, and then try to test it on our holdout set or a test set. Okay, so let's get started. Let's define some parameters maybe. So you know that in XGBoost we have a lot of parameters, and over here we'll be just sampling maybe 2 of them. We'll be sampling the gamma parameter and the learning rate parameter. So let's say 0.01, 0.03, and maybe something that's a little bit higher, 0.10. Or maybe let's just do this 0.10, 0.30, 0.50. Now, choosing these values itself is another story. Maybe you can look at some graphs for this. So try a learning rate, see how it's converging. Maybe is it going too low, too high? Is it underfitting? Then you can increase the learning rate and so on. But and then let's also look at gamma. Now gamma, as you know, is one of the regularization parameters, and it has to be less than 1. So let's try 0.1, 0.5, 0.71. So we have a total of 9 combinations that we can make out of these two lists. Now that we have made the lists, now let's call our XGBoost classifier, and then before that, let's also say how it's going to work. So let's say over here we have, so this is our base model. Okay, so this logistic here that you see in this example, this is our base model, which we then pass into randomized search CV along with our dictionary of parameters and some other extra things like random state or number of cores that you're going to use. I think it's called n jobs. So let's start with just creating a normal XGBoost. Right, so this is our base model. Now, if you train your data on this, it would work, but these will be having the default parameters, which may or may not be better than the params we have here. For this demo, we're just going to run it through 5 of these params and see which one is the best, and XGB will give us the best parameters, which we would then use. Oh, my bad. Randomized search CV will give us the best parameters, which we would then use. So right, so we have the base model, which is XGBoost. Then we also have the parameters. So I think it's called param distributions, right? This is params. What else do we have? Let's put scoring is equal to accuracy, and n jobs is equal to, let's say, -1. Sure, let's do this. We left off where we define these parameters and this random search. So I've also written a few more lines of code here where I do the trend test split and fit it on the trend data and call the accuracy score on the test data. I'm calling accuracy score here because I determined that as a scoring parameter here. Now, earlier I did mention that we weren't doing X test and whatever until we actually call random search with it. That's because we did not need to. But now that we have it, we have the score of 98.86%, pretty good. Now let's save this. Right, so I've just saved it using the pickle library. If you do not know what pickle is, it basically serializes Python objects that are string interoperable. So we have this model now, and we also have this mapping dictionary. So now given any input, we can just take all of these columns and like npk and all that, and then we can generate an output that looks something like from 0 to 20, as you've seen. And then using this mapping dictionary, we can then print out whatever output we want to give. So this concludes the first part of this tutorial. So at the end of part 1, we left off at this line, right, where we fit this random search object with x train and y train and we stored it. However, we made a slight inaccuracy here. We should have actually fit the best estimator of this random search rather than the default itself. So we can see that the best estimator over here has gamma value of 0.1, and it also has the learning rate of 0.1, which you can see was this and this. So now we actually have to fit this model instead. So once we've done that, and by the way, we can just copy this. So these are all of the parameters of our XGBoost classifier. So we store that in XGB best. So we fit this and we get actually the same accuracy score. However, that one was only what is called pseudo trained in the lingo, but this is actually trained on X test and Y test. Sorry, my bad. X test and Y test and tested on X test and Y test. And we've just rewritten the same a file with this XGBoost as follows. So now that we've done that, we can see saved model.sav has changed. And now let's continue on to part 2, where we use Flask and then we deploy Flask to Python anywhere, and where we can use this saved model.sav to make actual predictions on the web. Alright then, let's continue with our project, and this is part 2 of the video where we actually start to wrap our model, so to speak, into something known as Flask. Flask is a micro web framework and it's pretty easy to wrap your model around. So obviously if you're new to Flask, or even if you have used Flask before, a lot of the syntax can get maybe a little bit confusing. So I'm just going to use the bare minimum features today, and you can use this as a template for your own smaller models. So before I start, maybe let's go over what exactly we're going to be doing. So as of now, the only artifact we have is this model, which I've represented as this circle over here. And this is the .sav file, right, which we've saved using pickle. We also have the dictionary mapping, which we can use. So what we're going to do is essentially use Flask as a framework that loads the model somehow and stores it. And we're going to use HTML, more specifically a HTML form, to pass the data into Flask. Now Flask will manipulate that data into maybe a series object or whatever, passes that into the model. The model gives a prediction, and we use the dictionary to give the output back to HTML file. Now, Flask has something known as Jinja 2, which is a templating engine, which can be, you can think of it as like fancy way to embed Python into HTML. So you can see how this can be helpful, right? If we give an output back, we can render that straight into the HTML page. Now, in your head, there should be a clear demarcation of what's going to happen. If it's a first time user, or let's say I'm going to visit the website for the first time, obviously I do not have any inputs, right? I haven't pressed the submit button. So that can be seen as a kind of get method to Flask. And similarly, if let's say I submit the outputs back, that represents a post method. So when I call with the post method, I have to return this template with some extra parameters that would represent maybe the output or the crop that you're going to predict. And we're going to look into this in a little bit more detail, but as of now, all that you have to remember is we have a web framework, we have a HTML page, we have get and post methods, and we load the model in somehow. Now let's look at the Flask quick start module, which is actually really good, and it gives us a lot of things. So this is how we would initialize the app. So we import Flask, we initialize the app here, and we do something known as a route. So if you've done any API programming before, you would be familiar with what routes are. In this case, we'll only be using one route, which is we can use the base route, and we can just use this in our own app itself. So let's now go to the directory and let's make the structure of the application. Before that, let's maybe commit the original changes. Alright, now that that's committed, let's open up VS Code and let's start off with this. So we would be having to code up two files basically. One is the HTML file that will contain a form, and one is our main Flask file, which we can call app.py or really anything. And this will be helpful while deploying because we can run the Flask framework itself, and that will give us our outputs. And we can basically deploy the framework, which will serve up the web page, which will use Python as the backend. So let's start off with this. Before that, obviously we should install Flask. Let's do that. I have already have Flask 2.2.2 installed from a previous project. So let's right. So this is just from the quick start that I've just copied here, and let's in fact copy this part also, and we can always update it later. Right, so this is the main route, which is the base route. So that just means the URL and nothing after that. Of course, we can also change it. So let's maybe specify a port where the Flask app will run on. and cool, we can start. So instead of changing this, let's call it home or whatever. So just to make sure that this works, what we have to do is at the end of this, we have to actually run the app. In fact, let's see how we can do that over here. Right, so let's try. Alright, so we can see that we have something spawned up here on localhost 5000. This is typically the default port. Yeah, so we can see hello world, right? So the example has worked. Let's say it's not hello world, let's say it's hello flask or whatever. We should stop the server and run it again. Now, if any of you have used Flask or really any web framework before, you might be thinking why we haven't used debug mode. Debug mode actually has been proven to be quite sketchy while in production, and I'm normally quite a forgetful person, so I'll probably forget to turn it off. But sure, you can use debug mode here, do whatever you like. But before you deploy to prod, please remove debug mode, or before you like showcase your URL, whatever, please change the debug mode. I'm just keeping it like this because I'm used to it. So now that we have Flask ready, let's maybe mock a HTML form. And by that, what I mean is we have to have two methods, right? So we have the get method and the post method. So let's indicate that here. And we'd also have to import the requests module. Right, so if this is a post method, pass the form, else just return bare HTML page. So let's see how we're going to pass the form. So request.form dot get, sorry, just this, and this will return a string version of the form attribute which you give in HTML. So you give like an ID, right? So what do we need now? Let's look at the column names. We need all of these, right? So let's paste it here. And similarly we can, and lastly you have rainfall. Now that we have all of this, now what we must do is let's import. So the idea here is we create a series object out of this and then load up the model, and then we make the prediction and return it back. Right, now let's create a series object out of this. And now that we've done that, we have to load up the model and then we have to make the predictions. Right, so let's load up the model maybe. So let's import pickle. If you remember, model was in this file, right? Saved model.sav. So let's load it up. Right. For that, let's set model to none. Now that we have loaded up the model, we can now make predictions, right? So and we can maybe print label for now. And for this first iteration of the project, let's just pass out if the request method is get. And let's just render this template. Now, obviously we haven't imported this, so let's do that. So render template does exactly like it says on the tin. It renders an HTML file, which can in turn be composed of other links to, let's say, CSS or whatever. Now we have to make a folder called templates, and in this we need to have our aforementioned index.html. So let's now go to index.html. Now it's obviously empty, so let's create some content there. Now we need to create a HTML form, and what should that form contain? That form should contain all of these n's, p's, k's, and so on, and we put that in our like id. So let's go look at HTML form. Yeah, sure, this looks good, and we should obviously have a submit button as well. So let this load. Right, so let's just copy this over. Now this form action, obviously action page.php doesn't exist, but what does exist is our Flask app, which we will then, what is the route again? The route of a Flask app is our base route. So this will call our base route basically, which is why we have a post request there. So it will call this as an action, and then it will perform all the processing which we will now define. Right now, what we should be doing is essentially getting the parameters from here, parsing it through this, and passing it back basically. Now, okay, right now we only have a print label, and you can see that we have nothing to do here apart from rendering this template. So what should happen is we get the inputs, we pass it, and we get a print. Hopefully, we get something printed here, and that's it. And now what we have to do is change this up and make an else block, and then make change this part of this. Okay, let's continue. So we left off around at this point. I've changed this from a series object to a data frame object, and I've also reordered a little bit of these render templates here. But the bigger change comes in the index.html, where I have actually borrowed the styling of the original garden project, and you can see over here we have the same input types, although here we have a placeholder, a name, and we have another classes, and maybe a bit of a label, and so on. But everything else, the core functionality is the same. So let's run this and see if it works. And if not, let's try to maybe debug this. So that's a good sign. It loads. So we can see that there's an internal server error. That probably means there's an error with our file itself. So let's look at what it is. If using all scalar values, you must pass an index. Okay. Let's just Google this. Right. So interestingly, this could be while we created the data frame object for the prediction itself. So let's see what they've done. So they've set an index equal to 0 over here. So let's try that too. Okay. Now let's rerun the app and let's see what happens. Okay. So it loads. So for now, I'll just give dummy data like we did before as well. And let's see. Okay, so we can see that something has come here. We have a label of 15. And if you remember, this 15 is like a number, right? So it has from 1 to 20, and we've saved the encoding over here in this mapping.py file, which we can then use. So in this case, muskmelon is the crop that we were to grow in these frankly horrendous conditions of 1 pH and with 1 rainfall and like 1% NPK and so on. But okay, but our model works, and that's a good sign. But now, how are we going to push these outputs onto the screen itself? Let's say for this use case, let's say we were to make an extra div element or some extra paragraph element over here after this button, where we can maybe push our outputs to. That will be something nice, and that's known as Jinja 2. So basically, like I said before, Jinja 2 is a way where you can embed Python, so to speak, into HTML. So let's see. Let's look at the quick start maybe. Right, so let's look at Jinja 2 Flask quick start. Right. So what they do over here is essentially pass another parameter over here while returning the render template, where you could also do this like over here, as you can see. So we have a render template and we have a name attribute, which we then pass. And this can now be printed or iterated over in the HTML file itself. So let's do that. So let's go back to our app.py and let's call this, let's say label is equal to pred, and here we have a label equal to none. Now of course you might be thinking this is just a number, we have to convert this back to a string. That's perfectly fine. Let's see over here what we have to do. I think this was block content, right? Right, yeah, okay, so let's just use this. So let's maybe indent this a bit. So what this block essentially does is this creates a new div element, and inside this we have a conditional. So if name in this case would be if label, then we would print, this is the prediction. And if not, we would just print enter your values here. Okay, now that we have used Jinja 2 and we have incorporated that kind of label attribute over here, let's refresh the app and let's try again. So if you remember last time when we gave all of the inputs as 1, we had a label of, I think 15 it was. So let's see. So we can see we have a prediction of 15 here, just as we had mentioned like this. So now the last step to do over here is, now styling aside, of course, the last step that we have to do right now is to incorporate this mapping.py back. Now we can just load the file or we can import it from the file, but I'm just going to do the cheap trick here, which is basically just copy and paste this. Now, of course, if you were to maybe store this in a pickle file or any other format, you would then load it like how we load it here, or if not, just from import dot mapping, sorry, from dot mapping, import mapping data and so on. But okay, now before we continue, let's just print the type of this, or let's just print pred of 0. So ideally this should be an int. So let's run this. Let's run this back. Right, so we have 15 here, right? So that means this is an int. So we can just try some kind of reverse mapping here. So let's write a function here for that. So this is the default, no crop is the default return value if in case, let's say, give 22 or something. So in this case, it would be muskmelon ideally. Now we would unit test this, but right now, I think if we get 15 over here, we can basically mock the test. But ideally, we should unit test this function anyway. So now that we have the reverse mapping function called, now ideally we should get muskmelon on the screen when we enter our sacrificial inputs. Now I should have said superficial, but it's quite sacrificial. So right, we have muskmelon here. So we have essentially completed our end-to-end deployment of our model, but it's only locally. As you can see, the URL we have is localhost 5000. Now, sure, you can set up a temporary tunnel or whatever, but we want this to go big time. We want this to be shown to everybody, and anyone anywhere can connect to it with limited exceptions. So that's where we are going to host it now using Python Anywhere. So Python Anywhere is a website where you can basically host your Python projects, and you can also run Python code over there. So ideally what we want to do is we want to like expose this endpoint, right? We want to keep app.py running. So the Python Anywhere's port 5000 or whatever port can be used for us to maybe call this model and to get all of these crops. So I'll see you now in the next part where we deploy it to Python Anywhere. So just to summarize, right now we have predictions, right? So we can input all of our attributes and we can get our predictions out. So see you in part 3. Welcome back. This is part 3 of the video and the final part where we finally deploy to Python Anywhere. Before that, let's push all of our changes. Now, as mentioned before, Python Anywhere is a website where you can basically deploy your apps and so on. So I've created an account called ML Course. So this is the free account, and I've also verified the concerned email. You can see that you have 512 megabytes, and this is where the deployment part is really important. You see, this model is pretty small. It's barely a few megabytes. However, when you start to encounter things like NLP models or maybe computer vision or maybe neural networks with large amounts of parameters, 500 megabytes may not be enough. And particularly if your web app itself becomes quite complex. So that is something that you definitely have to keep in mind. That said, this will be more than sufficient for our example here. So we can see that it has been pushed. So now what we can do is let's go back to Python Anywhere and let's now open up a new bash console. So the idea here is we're going to download our code or basically clone the code through Git. You may remember we have pushed our code to Git first. And once we do that, we then are going to basically try it for the first time or try it ourselves. Right, so the idea here is we're going to pull our code through Git and then we're going to try it out. We're going to try deploying things in Python Anywhere. It's been quite some time since I use it as well, so it'll be really interesting. So first, let's see the repository that we have pushed our code. I think it was this one. Right, so let's clone this. So our app.py file is now in this path. So let's save that. So this will come in handy actually when we try to rewrite the file basically. So what this does, Python Anywhere does, is it gives us a very handy quick start guide where it has basically an empty file which we can then configure to our needs. So what we'll do is we'll use that. We'll create an empty web app, basically empty Flask application, And once we've done that, we'll then rewrite that Flask application with whatever is at this path which we just saved. Right. Let's go to Flask. I wonder what Python version this is. Before that, let's install maybe all the dependencies. I think that's it. Let's just confirm that. So we had Flask, Pandas, and XGBoost and sklearn. Okay. Right. So we already have quite a lot of things. Just to confirm that it's already been installed. Okay, it looks like it's all installed. So let's look at the Python. So this uses Python 3.10. Let's use that. Right, so this is where we have to put the path here. Okay, let's look at this. Ideally, we should get something like hello from Flask. That's because that app.py which we just saw has been rewritten now. So let's go to the files tab and let's look at this. So we can see that we have deploy ml is the name of the repo and we have app.py. Now this is suspiciously quite small and you can see this has just hello from Flask. Now what we can do is we have to just copy all of this and save. Right, now that this is done, let's go back to our files and just ensure that it has changed. Okay, yeah, it looks good. And now what we should do is we should go to web tab and attempt to reload this. Oops, something went wrong. Let's look at what has happened. Debugging is always fun, and Python never gives you a lot of these logs. So in our case, when we started to run the file, it actually didn't work. So we can go to the dashboard, or we can even go to the web tab, and we can see the logs over here. So there are three types of log: the access log, error log, and server log. The one that's most pertinent to us is the error log, because access log just tells us what browser or what kind of user agent has access to the um, deployed endpoint, and this is the server log which we don't really need right now. However, this is the error log which we actually had generated here. We can see that saved model.sav is actually not loading because it says the file doesn't exist. So what we did was just take the full path, so this path, and we change it up over there in this files tab. So that was one thing. So let's see why that is. Now, I still suspect this might not run. However, this is how we typically go about debugging such a thing. Because this is a deployment instance, there'll be a lot more maybe unforeseen errors that um, might crop up. So over here, you can see that this is slash home slash ml course slash deploy ml slash save model sav is the full path, and this seemed to work. So we can see that this has loaded. So let's try our infamous example again. Now, of course, in real life, you would be checking maybe something from the test set. Um, Right. So we have another error here. We have localhost 5000. So let's check the errors log. So we can see that actually nothing new has come. So this was a previous error as well. This was because I had changed the Python version inadvertently. But we can see the error here, right? It's trying to go to localhost 5000. And that could be because of one of two places. In the index.html, we had an action tab. And we also had one of the other things in the get and post part. So let's maybe look over here. So we can see that index.html is fine. However, when we actually go to index.html itself in the templates directory, we can see that this action here, we scroll down, maybe the form. This goes to localhost 5000, right? So this is obviously wrong. So what we should do is we should maybe go to mlcourse.pythonanywhere.com. Yeah, let's try this. Right, so let's try this now. So if you make a change or something and you want to go back, you have to go to the web tab and reload the app like so. Let's try it again now, maybe. So let's go here. Yeah, this seems to load again. Oh, something seems to be loading. Yeah, so I don't think that was the correct thing to set it as. So let's go back and close this up. Let's go to files and maybe let's remove the port 5000. So yeah, now let's try. So let's go back to the web tab. Let's reload it. Live debugging always gives us such a rush in it. So let this load. Okay, let's try this again. And let's see. So after changing that path, it did eventually work, although the classifier did take some time to produce the outputs. If you know of any performance tweaks to Python Anywhere, or if you would like to see any other method done differently, do let us know in the comments or on Slack if you're a student of the course. That said, all code for this particular tutorial will be uploaded on this repo as well. It is already here. So thank you so much for watching. We done a really interesting idea today of implementing a project end to end, and I hope you found it fun. Goodbye.